Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari John. Today we are looking at exponential equations. Exponential equations simply means equations that involve exponents or equations that involve powers or indices as it were. Okay, so we have some simple examples on the board. So in this video we'll be looking at these three examples. In our subsequent video, we'll look at some more examples, and then I think we'll do this for about three or four videos so that we can see how to approach different kinds of problem as it relates to exponential equations. Alright, so quickly we'll go straight away to solve this. This first question says we have 1 over 2 raised to the power of x is equal to 8. Recall from our law of indices that 1 over 2, recall this law, a raised to the power minus 1 equals to 1 over a. Okay, so we can write this as 2 raised to the power minus 1 raised to the power of x equals to 8. Okay, so using this relationship, we've been able to write this as this. I believe that is taken. So we can further, using the relationship again from laws of indices, a raised to the power of m, and is setting as a raised to the power of m times n. So this times this can apply. So we can do this times this. That gives us 2 raised to the power minus x is equal to, we can express 2 as 8 rather as base 2, so that it becomes 2 raised to the power 3. We can express 8 as base 2, so we have 2 raised to the power 3. So at this time the base are the same with equality sign here. This implies that we can say that minus x is equal to 3. Minus x is equal to 3. And so we can further say, multiplying both sides by minus 1, we can say that x is equal to minus 3. So that's the value of x. Very simple to solve. So here you multiply both sides by minus 1. Minus 1 times minus x gives us s, and minus 1 times 3 gives us minus 3. Okay, so pretty easy. Let's see how we can solve the second question. So to solve the second question, I'll clean here so I can use the board. We can use two ways to solve the second question. Let's see if the first method equals to 27. So we can first decide to divide both sides by 3. So if we divide here by 3, we have 3 raised to the power x divided by 3 equals to 27 divided by 3. So this 3 goes off with this. We have 3 raised to the power of x equals to 27 divided by 3 is 9. So again we can express 9 as base 3. So we have 3 raised to the power x. 9 is the same thing as writing 3 raised to the power 2. Okay, so we are done. Now because the base are the same, 3 with equality between them, we can say this implies that x is equals to 2. If here is 3, here is 3, then here will be equal to here. So that settles it. But we can also use another approach to solve this problem. Let's see it over there. Or we can say 3 bracket 3 raised to power x is equals to 27. Now from our laws of indices, we know that a raised to power m times a raised to power n is equals to a is equal to a raised to power m plus n, right? So applying that here, because this can be written as 3 raised to power 1 times 3 raised to power x equals to 27. Okay, so applying this law here, we can say this is 3, 1 plus x equals to 27 in base 3 is same thing as 3 raised to power 3. 3 times 3 times 3 can gives us 27, okay? So this implies that 1 plus x is equals to, since the bases are the same, then this power must be equal to this. So taking 1 to this side, we have that x is equals to 3 minus 1, and then we can say s is equals to 2. Our last example, which is example 3, it says 3x is equals to 1 over 81. Okay, so we can write this as 3x equals to 1 over, we can write or express 81 as a base of 3, so that gives us 3 raised to power 4. 3 raised to power 4, that is 3 times 3 times 3 times 3 gives us 81. Then here becomes s 3 raised to power x equals to, using the law that says a raised to power minus m is set as 1 over a raised to power m. I believe you still remember this law of indices. A raised to power minus m is equals to 1 over a raised to power m. Okay, applying that here, that means this can be written as this, which is 3 raised to power minus 4, and this implies that x, since here is 3, here is 3, it means that s is equals to minus 4. Alright, so these are very simple examples. In our next video we'll see some tougher problems. Okay, but then don't forget to like, to share, and to comment on this video. Thanks for watching. Bye.